there's this hidden conflict raging inside these very systems, a secret war for control over what they see, what they learn, and ultimately what they do. What if an AI, a system we're building to find patterns and give us straight answers, could be intentionally taught to lie, to look at one thing but confidently tell you it's something else entirely? And this brings us to the heart of what we're talking about today, the field of adversarial machine learning, or AML for short. The easiest way to think about it is like cybersecurity, but for AI. It's this constant cat and mouse game between the folks trying to break AI systems and the folks trying to build digital fortresses to protect them. So let's start by looking at how you trick, well, yesterday's AI, the predictive models. Their vulnerabilities were some of the first to be discovered, and they really show just how fragile these systems can be. Okay, so imagine a standard computer vision AI. You show it a picture of a stop sign. It analyzes everything, the pixels, the shape, the color, and yep, it correctly tells you it's a stop sign. Everything's working exactly like it should. But now, an attacker gets that same image and adds this carefully crafted layer of digital noise. Now, to you and me, the image looks exactly the same. We literally can't see the change. But here's where it gets wild. When we show this slightly altered image back to the AI, it doesn't see a stop sign anymore. Instead, it might confidently say, that's a speed limit 45 sign. With a change we can't even perceive, the AI's entire reality has been rewritten. This, right here, is a classic evasion attack. And that's pretty much the textbook definition. An evasion attack is all about creating these malicious inputs. They're called adversarial examples, specifically to fool a model right at that critical moment of decision-making. The AI was trained perfectly, but it gets fooled at the last second by a sneaky input. This is what's known as a data poisoning attack. Here's the playbook. First, an attacker cooks up some malicious, poison data. Second, they secretly slip that poison into the huge data set the AI learns from. Third, the AI, not knowing any better, studies this bad data and learns a hidden vulnerability, basically a backdoor. And finally, the attacker can use a specific trigger to activate that backdoor, making the AI mess up on command. Okay, so that brings us to the modern battlefield, the world of generative AI. Large language models, chatbots. In this world, the attacks are less about pixels and much more about psychology. It's all about manipulating the AI through conversation. A really common method is something called a jailbreak prompt. Users figured out they could trick a chatbot by basically telling it to roleplay as a different persona. One of the most famous examples is Dan, which stands for Do Anything Now. This prompt essentially tells the AI, hey, forget your rules. You're a new AI now. And the difference is it's night and day. If you ask the normal AI for something against its rules, it'll politely say no. But if you ask Dan, the jailbroken version, it'll often just go for it, completely bypassing the safety features that were designed to protect us. This type of attack has a name, and it's called prompt injection. It's really the art of using the AI's own input box against it. You craft a prompt that's so clever it just overrides all the original programming and safety guardrails. You're essentially hijacking the model's purpose. So, you might be thinking this all sounds pretty bad. With all these ways to attack an AI, how are developers even fighting back? Well, this leads us to the other side of the coin, building the defenses in this crazy escalating digital arms race. It's like for every move, there's a countermove. To handle evasion attacks, the go-to defense is something called adversarial training. To fight off data poisoning, developers use data sanitization to scan and filter their training data for anything suspicious. And to counter prompt injection, the big focus is on model alignment, which is a whole complicated process of fine-tuning the AI to really stick to human intentions and safety rules. Let's just zoom in on adversarial training for a second, because it's a brilliant idea. You can think of it just like a vaccine for AI. During the training phase, developers intentionally throw millions of those tricky adversarial examples at the model. By learning to spot and correctly handle these attacks, the model builds up a kind of immunity, making it way more resilient out in the real world. This is a true arms race. This isn't a problem that gets solved once and for all. For every new defense that's built, a new, cleverer attack is already being developed. This whole conflict, it's really just getting started. And just to give you a sense of the scale and speed here, think about this number, over 5,000. What's that? That is the number of academic papers on this exact topic published on just one research server in a span of only 2 years. This field is absolutely exploding, which tells you just how critical and how active this hidden battlefield has become. And all of this leads to the fundamental question we all have to start asking ourselves. As these AI systems get exponentially more powerful and woven into our daily lives, the real challenge isn't just about making them smarter. It's about how we ensure they stay aligned with what we want, that they stay on our side. Because in this hidden war, losing really isn't an option.